Good evening, ladies and gentlemen, and welcome to Sporty's webinar series. This evening, we're going to be discussing weather fundamentals and strategy, how to improve your pre-flight and in-flight weather decision-making. Weather is a very important part of aviation as we fly throughout the U.S. airspace system. It's a subject matter that we learn about during our initial private pilot training, instrument training, but it's really a topic that we never can stop learning about, as evidenced by the large amount of attendees this evening. And so we have a really great presentation to share some new and exciting topics related to the weather and how you can prepare for it during your flight. My name is Bret Koebbe. I'm with Sporty's Pilot Shop. I'm a flight instructor there, ATP, fly anything from RV, experimental aircraft, up through a Cessna Citation. So I've seen the gamut of weather at the low and high altitudes. I've been flying for about 18 years now. I also run our video production department, so I oversee a lot of our training for our private pilot training courses, instrument training courses, as well as all the applications that go with that using today's technology. With us this evening, we're very happy to have Scott Dimmich. Scott is our chief meteorologist at Sporty's Pilot Shop. He's our weather talent for all of our training courses, develops all the training material for those courses, including the instrument training course and our takeoff app, which I'll talk about later, a great resource for continuing education in the weather subject matter. Scott's a certified broadcast meteorologist in Cincinnati, Ohio, with more than 10 years of operational forecasting experience. And Scott's a real aviation enthusiast, flies a lot with us, so is really involved in the aviation aspect of weather as well. So a quick overview of what we're going to cover this evening. Scott's going to start off by talking about weather forecast models, how aviation forecasts are developed. And that's very important as we look at products that we know now, METARs, TAFs, forecast products, but also as we explore some of the other aviation forecasts this evening and talk about their limitations and benefits. But it's important to know how they're generated, and Scott's going to cover that in some pretty good detail. It's going to jump into aviation weather hazards. Some of this may be review, but also information to keep up with as we approach the thunderstorm season. So very good information there from Scott. I'm going to jump into from an aviation pilot's perspective on expanding your weather toolkit. Some new weather forecast products you can use in flight. Some products that are there now that you may not have realized that are there that can really expand your kind of outlook on the weather and kind of make you a weather geek, if you want to call it that, as you plan for your flights. Then we're going to jump in the airplane, talk about in-flight weather avoidance tools, things like ADS-B, SiriusXM, data link weather, and some practical tips for using data link weather along your flights. So with that, I'm going to turn it over to Scott here, who is going to jump into some aviation weather forecast models. Scott, welcome.
Thank you very much, Bret. Thank you very much for everyone at home or away from home that is joining us tonight for the webinar. We're here to cover a lot of topics related to the weather. I will be covering two sections, and my first section will be a little more brief. My section coming up will be a little bit longer. We'll talk about weather forecast models first, because you should know as a pilot how aviation weather forecasts are developed, not just where to get the information, but how meteorologists come up with this information. So let's start with the basics. Aviation forecasts are developed by meteorologists. Computers take information from all over the world, including from satellite, radar, weather balloon, surface systems, and a whole bunch of other information gets compiled together, and we as meteorologists will attempt to not just look and see what's going on, but make projections into the future about how conditions are changing. So we and computers take this radar, satellite, weather balloon, surface observation, and other data to predict future weather changes. Computer models have to simulate changes in weather conditions in the atmosphere over time and also over space. So you see two forms of air already coming in. Meteorologists have to interpret computer forecast guidance to make a weather forecast. And it's important to note that the two are different. When you see a human forecast, you're looking at what a meteorologist has produced. An example of that would be a TAF. That's different than computer forecast guidance, which is raw model output. Let's talk about the two main types of weather models. First of all, we have numerical weather prediction guidance, and that's abbreviated as NWP. That's where computers are taking complex mathematical equations plus all of these inputs to take the current state of the weather and project it into the future. We want to know ultimately the future state of the weather. But we don't just want computer guidance. We want to put something on top of that computer guidance to correct for errors. And that's where statistical guidance comes in. So after the numerical weather prediction has run, the statistical guidance comes into play, and that will take this raw computer guidance from the NWP, compare it to past observations, and correct for common or known errors. Not all errors, but at least the big ones. You should assume things about forecasts, but know that these rules aren't always true. Confidence usually decreases as you go farther out into the future. Confidence usually is higher for larger scale weather features. So if you are looking at guidance and you see a system that is large and expansive a day away, your confidence will be much higher than predicting the coverage and the intensity of thunderstorms a few days from now. Computer models almost always simulate smaller scale weather features like thunderstorms. So models will forecast for various points around the United States and around the world in some cases, but smaller scale features like thunderstorms are often handled by what is called parametrization, a very fancy way of saying there are processes working in the background to forecast smaller scale features. Computer models are rarely accurate with the exact placement and positioning of weather features, such as thunderstorms. You can't just look at a weather model and say, there will be a thunderstorm crossing over JFK at 5 o'clock. That's not how computer models work. But as we review trends in the guidance, we begin to see what is increasingly likely, and we can get a better sense of what the coverage and the intensity of the weather will be like. Don't fall into the trap. Higher resolution computer models aren't necessarily more accurate. They just produce higher resolution output, and that output could be wrong. The latest run of a computer model isn't necessarily the most accurate. If a weather balloon goes up and it samples bad data and it's not thrown out by the model, that's garbage in, which means you're going to get garbage out. So it's more important, again, to focus on trends and know that there will be some noise if you're looking at computer forecast guidance. Models, especially with the advancements in computer technology and processing, are getting faster. They're updating more frequently. But just because models are updating more frequently doesn't make them more accurate. No computer forecast model is going to accurately predict the weather all the time. And no human forecast, by the way, is perfect either. But meteorologists often have a skill beyond this numerical weather prediction guidance and the statistical guidance, or a blend of all of those different models. So forecasters are comparing what the computer guidance is predicting to what the guidance is predicting. So you have multiple layers going on, and that's how we can often beat the computer guidance. Surface maps, convective outlooks, the information that you look at most frequently as a pilot often comes from the National Weather Service, or that information in some way, shape, or form is tied back to National Weather Service data. These forecasts are updated throughout the day as we, meteorologists, and the National Weather Service and meteorologists all over the world look at the latest information. We're not just looking at models, we're looking at satellite and radar trends to tweak or change the forecast. So make sure that you're reviewing forecasts before and during your flight if possible, but also comparing that to observations. If you're a veteran pilot, you're probably very familiar with terminal aerodrome forecasts, or TAFs. In this country, that's a forecast created by a human being, a National Weather Service meteorologist. TAFs are valid within 5 miles of an airport, and they're usually valid out to 24, 30 hours. More recently, as more information comes into the cockpit, you may have heard a term called MOS, or Model Output Statistics. Like I said before, That's a computer-generated forecast and not a human forecast. And there are shortcomings to this guidance, but it is there to help you make your own decisions. MOS is simply statistical guidance developed from NWP models to correct for common errors. So that's an overview of the weather thus far. This is where I hand this back to Bret, and he will put this theory into action.
Thanks, Scott. Great information. And as we go through this presentation, we're going to build on each other's kind of talks here. And Scott had some very important points. Again, he mentioned the trend of weather, and that's going to be a continuing theme this evening throughout the presentation, is to monitor trends, because that's going to be one of your biggest clues as you plan ahead on flights. Sometimes as far as 5 days out, looking at these products. The other key takeaway here is, are we looking at a human forecast or a model? We're going to start off with the Terminal Aerodrome Forecast, the TAF. And as we go about this products, we're not really talking about how to go about a standard weather briefing. We're going to assume that you have access to flight service in your favorite application on the web. But we're going to take some of these elements and break them down and show you how you can augment them with some additional tools as you go about your weather briefing process. So TAFs are very important. They're critical to all pilots, VFR and IFR. Very concise amount of data that has information on precipitation, visibility, ceilings, etc., for a 24 to 30 hour period. Now, as great as they are in that very concise, viewable, easy to digest format, there are limitations there. They're limited to a certain amount of characters and size. And there's a lot more that a meteorologist is probably thinking, and definitely is thinking, when they generate that TAF. And so an item you can use to supplement that, especially on times when there's a lot of gray areas and you want to get a little bit more information about what's going on, is a product called the Aviation Forecast Discussion. And in this example here, we're looking at the preflight app, which includes the Aviation Forecast Discussion on the airports page. We're looking at the weather tab. And then just under the MOS tab there, we have the forecast discussion selected. Now, what you're going to see here is kind of into the mind of the meteorologist. What were they thinking when they generated that TAF? What are the weather conditions? What are the low pressure systems doing? Things like timing are very important because, again, TAFs can be pretty general over a 2 to 4 hour period, but you can get the sense of their confidence in why they generated the certain lines that they did in that forecast. A very common one you'll see, especially in the summertime, is the VC SH or SHVC, showers and vicinity, a very broad forecast item that could mean a lot. It could mean convective weather, could mean light rain showers. And as Scott mentioned, numerical weather models can't predict exact locations of this weather. But what you can start to read here in this aviation forecast discussion is the timing of these weather systems, when they're going to move through. And again, the confidence level in the meteorologists and what they were thinking when they developed that. If you're not using preflight, but of course have access to the internet, the Aviation Forecast Discussion is also available on the Aviation Weather Center website, aviationweather.gov. And these are split up, as you can see in the picture here, into regions around bigger cities. So each state might have 3 to 4 of them for a particular area. But go ahead and click on those, especially when flying into regions, say a mountainous region, Denver, Colorado, or maybe a coastal region out near California. An area that you're not as familiar with the typical weather, the local weather that takes place in that region, it can give you some good insight to things like marine layers or fog developing in valleys and how that might play out. And again, the confidence level from the meteorologist and how long that condition may exist. So switching gears, but in that same kind of area there, again in preflight, talking about forecasts, Scott mentioned the model output statistics, or we commonly say that as MOS, as the abbreviation and acronym there. So this is a computer forecast, no human intervention here, out to about 3 days out. Now the nice thing about this product is it is statistically improved over time using historical data from a given site. So we're not just taking raw data from that given day, but it's also saying what's happened in the past and improving that forecast. Now a nice thing here compared to TAF is that it's available for over 2,000 airports in the United States, where of course the TAF is limited to the major metropolitan, the big Class B, Class C, Class D airports. A TAF or a MOS is going to be available for a lot more of the rural community areas, places where the TAF won't apply with its 5-mile limitation around those bigger airports. So here we're looking at preflight, and the MOS is accessible in a decoded format just below the TAF section there on the weather tab. Now, what you're going to find, as Scott mentioned, weather forecasts tend to be more accurate in the near future, less accurate down the road. But if you're planning a flight, say 2-3 days down the road, this can give you a good indication of what the trends are, how the conditions are expected to develop. If you're a VFR pilot, it can give you some clues about whether or not the weather will be at least VFR, possibly. And as you watch these forecasts, as new ones are generated, you can again see the trends of what the forecasters are expecting out to 72 to 84 hours out in the future. Now, the MOS has a lot of information. It has things like ceilings, visibilities, temperatures, precipitation, all kinds of weather variables, and it can be overwhelming to look at all that data all at once. So there are graphical forecast charts that take particular elements from a MOS. In this case, we're looking at just the ceiling element. Again, now we're in ForeFlight here. On the left-hand side, you can see a screenshot of where we're at. We're on the imagery tab of the product, and we're looking on the left-hand side. There is a label for GFS MOS, and we're looking at the ceiling forecast. So again, this is long-range planning. You're not going to use this to pick an airport or an alternate for your flight coming up based on specific ceilings. But maybe 12, 24, even 2-3 days down the road, it's going to give you a feel for what the weather's doing. So in this case, it's just the ceiling, and the black areas, the empty, non-colored spaces, forecasting ceilings over 12,000 feet. So really good VFR weather. As you dial into the greens and the yellows and the oranges, we're getting down into the 200 to 400 foot ceiling range. So again, long-term planning, probably some low pressure systems there, possibly a cold front, and some precipitation to go along with that. But again, a VFR pilot, say going out on a weekend trip, leaving on a Friday, they want to get back that Sunday sometime, it can help you determine if you need to shift your plans a little bit and kind of plan ahead for that kind of condition. Now, along the same lines, there is a similar chart for visibility using a similar color scale. Again, this is in ForeFlight here we're looking at. Out to 84 hours, visibility obviously just is limiting for a lot of pilots, especially VFR pilots, for longer range trip planning. But the black areas there, we're looking over 6 miles of visibility, down to half to a mile or so in those yellow areas. But these are forecast in 3-hour intervals. So again, kind of go through each step of the way and see how the weather's forecast to change and get a feel for what's expected in the days ahead. For those not flying with ForeFlight or not with an iPad, these charts are available online through the National Weather Service. There's the website there. Rather than scrambling to write that down, if you do a Google search, it's just as easy to find these forecast charts. And you can look at other items too, things like temperature, precipitation, wind, snowfall, all kinds of data. But again, remember, these are computer models. They're not extremely accurate. They're not brought along with a human to put that element on the forecast, but a good assessment tool to look at for long-range planning. Now, as many know, the textual area forecast was discontinued recently. That product had been around for 30, 40 plus years. Got a little bit long in the tooth, not as useful with a lot of the graphical weather products out there today. And the FAA replaced that with a product called the Graphical Forecast for Aviation. And that's a pretty multifaceted tool on the Aviation Weather Center website. There's a lot of things here you can do, like plot METAR, visibility, ceiling reports right on a moving map on the Aviation Weather Center website. But one element here I want to point out that can augment your weather briefing is something the Aviation area forecast did, the old text format, is give you a forecast of cloud tops, which can be very useful different times of the season. Say in the wintertime, if you want to know the thickness of a cloud layer to climb through it to get on top. Summertime to get a feel for the layers as you fly about the US. So a couple things I'll point out here as you get to the graphical forecast for aviation. And you'll see that abbreviated GFA is the acronym for that. But when you get on here, if you click on the clouds button here at the top and then forecast, you'll have options here for tops, coverage, and base. So here's an example where my mouse is, if it's viewable here. You can see that it says the cloud layer there is overcast at 2,500. That'd be the bases, tops at 6,000. Now, a couple caveats. This is, again, numerical data. It's computer generated. This is not done by human observation. Human has not intervened with this data, but pretty good information on a wide scale, except when you're looking at intense weather systems, convective activity. You're not going to get a good feel based for things like thunderstorm tops or multi-layered systems when there's a lot of convective and lifting action in the atmosphere. Think of this as a useful tool on those days when you have stratified cloud layers not associated with big scale weather systems. So as a test, I went out on a flight. This was last year. I took a screenshot before we took off. We were heading south out of Cincinnati, originating there at the base of that top yellow arrow where it says overcast 5,000, tops at 5,500. And it was spot on. You can see a picture there we took out the side window, breaking out on top there, right at 5,500. And I took a second picture where it forecast central Kentucky near Lexington there that the cloud layer was forecast to break up. And sure enough, as we crossed that kind of boundary, you can see the cloud line started to break up there and go to pretty much a sky clear condition along the way. So good advice here on this kind of tool is not to use it to make real concrete decisions. Use it to augment your decision making, but start using it now and get a feel for it and the information it can provide. One more thing I'll point out here at the very top, you'll see a time slider. So right now it says we're at 18 Zulu, and you can extend that out. Looks like out to 8 Zulu there, so you can get a forecast several hours down the road of what the cloud tops are expected to change to. Okay, with that, I'm going to turn it back over to Scott, who is going to dive in a little bit more on aviation weather hazards.
Thanks, Bret. And as he transfers over to me, it's worth reiterating two important points here, and that is you should never let the bad weather in front of you become the bad weather around you. And when we're talking about computer forecasts, we're talking about guidance. The key word there, the key part of guidance being guide. Inform your own decisions. Do not let the technology make the decision for you. Now, I mentioned a little bit earlier in the presentation that I would spend less time on the weather theory, the ground, before we get in the cockpit analysis, and a little more time on this section coming up. Because, as we know, one of the biggest threats, if not the biggest threat that you have as a pilot, is weather and unknowns. So we're going to spend some time talking about aviation weather hazards, what causes them, and what you can do to identify those threats before you get in the plane. Also worth noting, we're still in, quote, ground school here. We will be taking our knowledge of weather into the air coming up shortly. It's not uncommon as a pilot to fly out one day and enjoy scattered cumulus clouds, if not sky clear, and then the next day we deal with thunderstorms, showers, clouds. As I alluded to a moment ago, most hazards to you as a pilot are tied to weather, including but not limited to fog, low visibility, showers, thunderstorms, icing, turbulence. You should be looking for all of these hazards during your briefing, and you should always be alert for changing weather conditions. I can't tell you how many times as a meteorologist I have looked at numerical weather prediction or statistical guidance suggesting there will be no showers or thunderstorms, and surprise, I look at radar, I look at satellite trends, and I see clouds and showers inbound. So don't let computer guidance guide how your flight is going to go and what weather you may or may not see. Let's talk about icing, a significant threat. One misconception, rime icing. It's not caused by ice in the clouds itself, but instead it's caused by supercooled water droplets. That's liquid water being suspended in a cloud or in a sub-freezing environment within a cloud. That liquid usually freezes on contact with your airfoil if it's cold enough. And this is driven by lifting. It's not just the fact that there's liquid in a sub-freezing environment. The lift being generated by your airplane causes air to cool and condense, so that liquid is freezing on contact with your aircraft. Again, this is stratiform icing, and odds are good as a pilot that you will encounter icing in a stratiform form and not a cumuliform form. And we'll discuss that more in a moment, but I want to reiterate that rime icing is not caused by ice itself in the clouds, but by super cold water that comes in contact with your aircraft and freezes. That's driven by the lift created by your aircraft. When should you be concerned with icing? I would say start with what your outside air temperature is and be looking for icing. Most icing occurs when the outside air temperature is between 0 and 20 below 0 centigrade, especially between 8 below 0 centigrade and 12 below 0 centigrade. In Fahrenheit, 32 degrees Fahrenheit to 4 below 0 Fahrenheit is your big window. your small window in the teens, especially low to mid-teens. So that's an overview of stratiform icing, which you are more likely to encounter over cumuliform icing. Cumuliform related to cumulonimbus, cumulus clouds, larger vertical development. With cumuliform icing and clouds, the cloud droplets are larger, and the icing is often confined into the updraft part of the cloud and mature storms. Why are you more likely to see stratiform as opposed to cumuliform icing? Because wise pilots like yourself are probably going to avoid mature storms anyway. But know that icing is a threat with thunderstorms and even vertically extending cumulus clouds. Cumuliform suggests larger vertical development. Stratiform, horizontal development. Now, clear icing is more likely in growing cumulus clouds. That's different than rime icing. And again, this is just one hazard, and there are two different types of icing. So make sure you're looking for both of these forms, and the texture of the clouds can often give you a clue as to whether you're going to see clear icing or rime icing as a more likely threat. There's a lot of discussion in the weather community, especially as we get into the warmer months of the year, about stability. Stability is inherently linked to the temperature and the dew point changes near and above the ground. The dew point, again, an absolute measure of how much moisture there is in the air. And as we all know, pilots, meteorologists, and even the general public, temperatures and dew points change as you go away from the ground. For that reason, different layers of the atmosphere can be stable and unstable at the same time. So it's a bit of a misnomer to say this atmosphere is unstable. There can be extremely unstable air at the ground, but if there's stable air aloft, that warm, moist air may not be able to break through that stable layer of air, escape to the upper part of the atmosphere where weather occurs, and create convection or thunderstorms. So it's important to not just look for instability. We should also be looking at layers of stability and instability with increasing altitude. What should you be looking for as a pilot? You need several ingredients, but you don't need all of them. It always helps to have a lifting mechanism like a cold front or a warm front nearby. But remember, even a trough, an elongated area of low pressure, can be enough to kick off storms. The positioning of the jet stream makes a difference. It's not just the intensity of the winds aloft, it's the positioning of the jet stream. And something that meteorologists and pilots often don't think about immediately is wind shear. That's the change in the speed and the direction of the wind with increasing altitude. If we have a couple of those ingredients, we may have some thunderstorms. If we have all of those ingredients, we're probably going to get some thunderstorms. But knowing whether or not there are going to be storms is only part of what we should be looking at. We should be looking at the threats. What are the specific hazards to our aircraft? A good place to start, freezing levels. Lower freezing levels support a larger threat for hail and a higher threat for supercooled water, especially if you're going to be near or going into convective clouds, which, by the way, I sure hope you're not doing. You should also look for wind shear. If you find that the direction of the wind close to the ground is out of the southeast and it's out of the west, 10 or 20,000 feet above the ground, that's a significant change in the wind direction, or what meteorologists call directional shear. If you see the speed of the wind rapidly increasing as you go away from the ground, that's another signal that there's shear. In that case, it would be speed shear. And when you have a combination of the two, you can often get vigorous thunderstorms like supercells. So simply looking at the wind direction near and above the ground, both the change in the direction and the intensity of the wind, that can give you an indication for how organized and how intense thunderstorms are going to be. But let's go back to instability. That's sort of a nebulous term. Meteorologists are looking at a lot of different things when we're looking at the threat for thunderstorms. And every environment is different. But as a general rule of thumb, you should be looking for relatively warm air near the ground and moist air near the ground. There are some regional differences here, but As a meteorologist in the heart of the country, a dew point of 50 plus is almost always needed for thunderstorms. 60 plus for a dew point is ideal. That's when you start to get into humid air mass or summer-like humidity. You also, near the ground, want a low dew point depression. And that's what you can see in foreflight, that difference in the temperature and the dew point. If that number is low close to the ground, you've got saturated low levels, and if that air is able to escape into the upper part of the atmosphere, look out. Probably going to be some intense thunderstorms. But we're not just concerned about what's going on near the ground. Cold, dry air aloft can also help that warm, moist air continue to rise. And as I mentioned a while ago, wind shear is important. That's a big change in the speed and the direction of the wind with increasing altitude. If you see a lot of wind shear, you can expect storms to be longer lasting and probably stronger too. Now, we talked a lot about weather theory, but you should also be spending some time away from the radar and not buried in your meteorology books. Let your eyes outside the window tell you what's going on. Cumulus clouds that are developing and growing vertically are a threat to you because that may be a developing thunderstorm. And if you look out the window and see a picture like this, where you have an overshooting top, a cauliflower-like shape on the top of a thunderstorm, that's a good indication that that storm is very strong, if not severe. Now, a wise pilot would stay away from it, but remember, you don't want to be near that thunderstorm either, because what goes up must come down. There's usually an associated downdraft or series of downdrafts to compensate for the updraft. What else should you be looking at as you pan around outside the windows? Well, simply put, your eyes are a leading indicator of weather. And the radar and satellite imagery that you're getting on your iPad or on your device in the cockpit, that's a lagging indicator. It may be as long as several minutes behind. In some cases, 10 or 15 minutes behind. You should always be checking your timestamps, but what's going on outside the window is live. So you should trust your eyes over technology every single time. Technology is helping you make your own decisions. It should not be making the decisions for you. And remember that radar and satellite trends, especially with bandwidth concerns nowadays, some of that data is processed so that it's not sending the raw satellite imagery all the way up to your cockpit. So don't let the radar and satellite imagery that you're looking at replace your own decisions. There's a clear indication of a thunderstorm outside the window. Let that guide your decision more than what you're seeing on the radar. And as we mentioned earlier, computer forecast guidance is not necessarily reality. Radar and satellite are short-term assessments of the weather that have actually happened. Computer guidance is looking into the future. Now, with time, you may spend an afternoon, an evening, a morning before your flight looking at this computer guidance. Interesting to see what it reveals or what it may show as you travel back home or for your flight coming up in the next couple of hours. But remember, if you're looking at computer forecast guidance, that's not reality. You should be comparing that forecast data to surface trends, to satellite trends, and to radar trends. The trend is important. The difference between the radar and the computer forecast is important as well. And always let your eyes come first. Short-term decision-making tools like satellite and radar come second, and computer forecast may be a distant third, especially if it's raw guidance. TAF's, different story, higher priority. So, as we've highlighted time and time again in this presentation, make sure that you're looking at the trend in models, not just looking at the latest model snapshots. If you have a flight coming up on Sunday, you should be looking a couple days out for what the hazards are going to be, what the timing is going to be, and if there's a shift in the timing or the intensity of the system, if not a big threat increase showing up in TAFs or other human forecasts. Remember that models have different solutions. There are a lot of different models that meteorologists are looking at, in addition to satellite and radar trends. So make sure that if you have access to more than one model, that you're comparing them, you can also see changes in the models over time. And this is where, as an added bonus, as a veteran pilot, the more time you spend with technology, the more familiar you're going to be with how models work, and you're going to see biases over time. And that will help you in your decision making. But remember, computer guidance is not there to make the decision for you. Your safety is your responsibility. Your eyes looking out the cockpit will always overrule what you are seeing on your iPad or device. Now I'm going to toss things back to Bret, who will again put this theory that we have described into action.
Thanks, Scott. And a couple of questions we had come through. We're going to dive in a little bit deeper here momentarily into in-flight weather avoidance. As Scott mentioned, using the radar timestamp and looking out the window. And we're going to actually cover that a lot more detailed coming up. So now I want to jump into, still on the ground here, we're evaluating the weather. We're looking into our decision making for a given flight. And I want to bring up a trap that I see a lot of pilots flying into, especially as a flight instructor and working with students and doing flight reviews, etc. It's so easy now to bring up your iPad and put your flight plan on there. Like example here, we're looking at a flight from Lunken to Charlotte and looking at the moving map screen. A lot of good information. We have the radar display, we have lightning strikes, and a good radar gradient shown on the screen. And we look at the METAR, right, for Charlotte. It's clear. There's so much more going on with this picture here that we can tell by just looking at that map display, especially when it relates to convective activity. What time of day is this? You know, is it afternoon? Is it morning? Where's the low and high pressure systems, cold fronts, etc.? And that's what I want to dive into here. As Scott talked about some of those aviation weather hazards. What are some additional tools we can look at outside of the full flight service weather briefing, but tools you have access to in ForeFlight and on the Aviation Weather Center website, so that you can avoid that radar METAR trap and not just look at the basics each time. So let's review kind of a 101 fundamental of weather briefings, which is to generally get the big picture first. We want to know what's causing the weather. Things like the surface analysis, where are they getting the low pressure systems, the high pressure systems, prog charts if we're looking out into the future. We're going to look at the radar imagery, of course, is very important for assessing a real-time view of where the precipitation and convective weather hazards are located. Satellite imagery, which we're not going to get into a whole lot. But then as you kind of understand what's going on there with the big picture of your flight, especially important when flying longer distances, higher performance aircraft, then you want to dive into the details, the METARs for the particular airports at your departure and destination. Of course, pilot reports, really one of the most undervalued tools out there today to get a feel for what the conditions actually are at altitude. The TAFs, the MOS forecast that we showed earlier. Again, to kind of get that full weather view of what's going on with your flight. Now, of course, two different flights might have two different approaches. A flight across a very clear VFR day over 50 miles without a cloud in sight isn't going to take as much time and weather analysis as the same flight crossing a cold front or possibly with a stationary front in the area with thunderstorm activity forecast. But these things all need to come together over time, and we'd also don't want to wait until the last minute right before the flight to get a feel for what's going on, especially if it's a flight that's important that you need to make. And so my weather briefing, when I have a flight coming up, especially one that's very important, somebody needs to get somewhere, I need to get somewhere, my weather briefings often start 5 days out. And it might sound silly, but it's as simple as looking at your iPhone or your Android phone and looking at the 7-day forecast, looking at the temperatures, looking at the little icons. But you can gain a lot of information there. You can see things like temperature trends, right? So if you're planning a flight, say this weekend, to the coast, and it's 80 degrees today, 80 degrees tomorrow, but come Friday it shows 65 as a high and 40 degrees as a low. You know, a good 15 to 20 degree temperature change probably indicates a cold front's coming in. So even though you're not even diving into your aviation app, but just looking at the weather tools on your watch, on TV, on the local news, can give you indications about what the weather trends are, even before you dive into the specifics in your mobile app or with flight service. And that's where you can start at that point digging into the prog charts. Common charts we're all used to showing weather feature, surface weather features out to 7 days out in the future. Another chart we're going to look at here in the middle is the convective forecast chart, so we can see where areas of thunderstorms are forecast out. Another one we're going to look at on the top there is a probability of precipitation. So we can see where the likelihood of precipitation across the United States. And again, with precipitation usually comes weather hazards, icing in the wintertime. And with strong cold fronts and even warm fronts, we have that kind of instability and convective activity in the summertime. So monitor the trends, see what's going on. Another benefit of that is you can see as the forecasts are updated, is the weather intensifying in that forecast or is it weakening? Again, can give you an indication of the actual conditions as you get close to that point for your flight. Then when it comes time for your planned departure, you can go in and dial into the actual real-time displays of radar imagery to pick your routing, make that go, no-go decision. But you're going to find if you spend several days out before that, you're going to feel a lot better about knowing the conditions, the movement of the pressure systems, etc. So again, mentioned the prognostic charts, surface analysis to gauge the locations of the low pressure systems, the cold fronts, when they're expected to move through. And not only just to prepare for that, but it can influence your flight timing if you have the flexibility. And that's the beauty of general aviation, is we can change our flight times and move around to fit our schedules. You may find it important to leave a little bit earlier or plan ahead and leave an extra day on your vacation and come back a day later. But not waiting until that last second can really help you with that, make you feel comfortable about the decision you make on that flight. So I mentioned we want to think about expanding your weather product toolkit. So these are charts here you're not going to find typically on a flight service weather briefing. They're buried sometimes on the Aviation Weather Center websites. And also, fortunately, ForeFlight, app that a lot of us are using, bring those charts to the imagery section of the app. So I want to show you how you can use those to, again, think about some long-term planning as you make your decisions along the way. So again, the probability of precipitation, the convective forecast, and the convective outlook. So where are you going to find these? Again, the imagery section of ForeFlight in the US weather section there. That's where you're also going to find your surface analysis and your prog charts, charts you may be looking at now. But there's a couple more in there that we want to take a closer look at here this evening. So another one they put in here is called the quantitative precipitation forecast. A big fancy word that basically a chart that indicates how much precipitation is going to fall to the ground over a 6-hour period. Could be frozen precipitation, could be snow in the winter, but more realistically in the summertime, it's going to give you an indication of the intensity of a storm or weather system, how much moisture is going to fall from that storm to the ground, which also usually indicates lower ceilings, lower visibilities. Again, kind of put that together, as Scott mentioned, these weather hazards typically found in weather systems, but also bring the hazards to flight that we try to avoid and plan around. So what this QPF forecast will show you here, and you can look over a 6-hour period, but it's also going to help you gauge frontal movement, low pressure systems, and also get a feel for their intensity. Again, how much moisture and instability might be in there to deliver precipitation on the ground. And these go out to 84 hours in the future. So again, a great tool for 2-3 days down the road to take a look at and get a feel how the weather is going to evolve in the days ahead. From a thunderstorm planning forecast, there's a couple products in ForeFlight. One is a short term, which they call the convective forecast. This will go out to 8 hours in a given day. So this is the forecast you're going to look at. Let's say you're waking up at 8 o'clock in the morning and have a 2 o'clock in the afternoon flight, right when all the afternoon heating occurs and the instability really starts to aggravate the atmosphere. And you want to know where the areas across the US that are going to have the potential for convective weather. So here we're looking at a Friday 18 Zulu chart, and you can see there in the gray or the blue crosshatch sections, areas that are likely to have convective thunderstorm activity. I won't go into details of what the crosshatching versus the lighter areas mean. You can save that for another time, and easy to research the legends online. But basically areas where there's convective activity forecast. Now the partner to that is the extended convective forecast. This is going to go out to 78 hours in the future. So again, if you're planning a trip a couple days down the road, want to get a feel for what the activity might be for long-range planning in terms of thunderstorm activity, that extended convective forecast chart is a great help there. Now another resource, and this one is referenced quite frequently on TV, the Weather Channel, but you're also going to find it in ForeFlight, is the convective outlook chart. And this is more of an outlook on how widespread severe weather activity is going to be. So in the areas I like green there, the general area, might be some pop-up thunderstorms, some weather that you could probably avoid, zigzag around it. When you get into the slight and enhanced areas and the high areas where they get darker colors that we'll look at here in just a second, those are areas where severe weather is going to be much more widespread. Areas you're probably not going to be able to fly through with typical GA aircraft or fly above, of course. But again, a good feel to get a feel for how the thunderstorm activity coverage will be for a given area. So here's a screenshot. I took this last year. This is right before Sun and Fun. And you can see in that high area there, the pinkish color, a color you don't see used very often. But this system actually brought a pretty good tornado outbreak across southern Georgia. But let's say you're looking at this a day in advance, and you see a weather forecast like this, probably a pretty good indication you're not going to be making a flight from Kentucky to Florida. So if you really had to get somewhere and you were watching the trends in the weather, it'd probably be a good clue that you need to leave a day early or postpone your flight. But if you waited until that given day to take a look at this, there's not a whole lot of options of how to make that flight across the southeastern part of the United States. But again, this is called the convective outlook, and it gives you a good clue of the severe weather coverage for a given forecast area. So as Scott mentioned, most of these forecasts, with the exception of that convective outlook, are computer generated. So again, they're not perfect. They're not going to be used for very micro scale forecasting for a region, but it can give you a big picture. Again, to watch trends, how things are evolving over time. And don't always assume that just because you see a big swath of crosshatching over an area, that's over typically a 6-hour period. So there's a lot of movement in thunderstorm activity, a lot of dynamic changes. So it tells you really just need to be flexible with your plans and might need to make a little bit of a deviation around weather or deviation with your actual timing of your flight plan. So let's pop back over to ForeFlight again, because there's kind of some confusing wording here in some of these aviation forecast charts, because there's actually another convective outlook. And this is misleading because it's the same word, but it's a completely different type of forecast and completely different generation method. So when in ForeFlight, from the list of drop downs of your layers there, you have the AirMet, SIGMET, and CWA, Center Weather Advisories. If you turn that layer on, what you're going to see, of course, are AirMets, and using the filters at the bottom, you can turn on icing AirMets, turbulence AirMets, IFR weather AirMets. But the one I want you to isolate there, as you can see with the red ring at the bottom, is the TS, or thunderstorm layer. And what this is going to show you are SIGMETs, the common SIGMET, convective SIGMET with the red boundary line, which outlines usually typical areas of severe weather. But what you also notice there is that yellow boundary, which will also come up when you turn on that thunderstorm layer. And that's a convective outlook. And if we just isolate that there, it's going to show you areas, outlining areas where thunderstorms are expected to develop over the next 2 to 6 hours. And again, the reason I bring this up is this is actually issued and developed by humans, by meteorologists at the Aviation Weather Center. So they're taking a lot of this data, a lot of this model data and forecast information, and making a helpful outline to see where convective weather might come up. So a really good, useful tool in the summertime, say mid-morning when you're planning a flight, to turn this layer on and see where the areas of convective weather might be appearing. A lot of times you'll see this yellow boundary show up in areas where there's not even any precipitation or radar imagery showing on the map yet. But again, areas that are forecast to have that information. So again, called the convective outlook, and you can find that there in ForeFlight in the AirMet SIGMET layer. Okay, so Scott mentioned icing, something we're always concerned with, primarily in the wintertime, but can happen in the spring and even summer at the higher altitudes. And there's a lot of different forecast icing tools, and given the season right now, we're not going to spend a whole lot of time on it, given that we're approaching the warmer weather. But ForeFlight did add a forecast icing tool to the map layer there that we have outlined in red on the drop down. But what I want to tell you here is it's very important to know what you're looking at, because there's lots of different icing forecast products. And again, this is computer generated. This is not human generated, nor is it actual real-time assessment of icing conditions. But this forecast icing layer here in ForeFlight is forecasting severity. which means how fast is ice expected to accumulate on your aircraft if icing is present. And sometimes you'll see some red cross-hatching in there too for super cold water droplets, which means there's even a more increased risk of severe icing in those conditions. And the reason I bring it up is you're going to find other charts. For example, Garmin Pilot has icing forecasts as well that allow you to look at probability of icing. And there's really a lot of difference there. You could have a high probability of trace icing. It's completely different than a low to moderate probability of severe icing. So you want to know what the intensity is of the icing product in addition to the probability. So take these icing layers and know what you're looking at as you display them in various products. Along the same lines, in forecast, they also offer a turbulence tool. This is another helpful tool, more for the comfort of your flight. Might be able to help you pick an altitude or a route that avoids turbulence. But again, know what the product is telling you. This is turbulence intensity, and it's telling you areas outside of convective weather. So very useful for predicting clear air turbulence, mountain wave turbulence, etc. But know that if you have a lot of convective weather, thunderstorms, and you fly pretty close to it, you're going to have severe turbulence as well. So again, know what the product is telling you and use it accordingly. With that, I'm going to turn it back over to Scott now, and Scott's going to dive into some in-flight weather products as they relate to SiriusXM, ADS-B, etc.
Bret and I have taken you on a weather journey thus far that is more or less the equivalent of ground school. We have given you 2 iterations, meteorology and from a experienced seasoned pilot. And now we're going to take that knowledge that we have acquired, both learning tonight, but going forward in the days and the hours leading up to our flight. Let's take what we know and understand about the forecast and use that in flight. We did a short weather lesson, we did a longer weather lesson. Now our lesson is going to be taking what we have learned and putting that to use in flight, and especially using our data link weather to make decisions. You have 2 main choices for data link weather: ADS-B, which you are hopefully familiar with. If not, you've got a couple more years to get familiar with it before the mandate kicks in. And you have another option, SiriusXM. Perhaps the most significant difference is that ADS-B is free and SiriusXM will cost you money. Now, worth noting that the 2020 mandate does not say that you have to use one or the other. You don't have to use ADS-B weather if you don't want to. The choice is entirely yours, but those are your main options for in-flight weather, and there are pros and cons to either one. For SiriusXM, and you have ForeFlight, or you have another device, it works at any altitude. It covers the entire United States. You get reception on the ground. You get reception in southern Canada, northern Mexico, and western parts of the Caribbean. You can see on the map the blue shaded area where you're going to get SiriusXM coverage. That's a little bit different than ADS-B data link weather. So the process here is you have ground-based towers that transmit data to a device like your Stratus in flight, and that gets passed along to your iPad, where you can look at real-time weather information, you can look at guidance, you can look at TAFs, you can look at a variety of information. Now, ADS-B behaves a little bit differently from SiriusXM weather in that it depends on your altitude. On the right, shaded in blue, that is the coverage, more or less, according to the FAA, at an altitude of 1,500 feet. You can see more limited coverage, especially out in the mountainous areas of the Rockies and in the central and northern plains. Once you get up to 5,000 feet, the coverage goes a little bit higher. You see more of the map filled in, especially in the plains and in the Rockies. Nice solid zone of coverage, especially in the eastern 2/3 of the United States. That again for ADS-B. Now that we know what our options are and we have a basic understanding of where we can get information, let's talk about radar. Perhaps one of the most important tools to a meteorologist, especially when we're looking at real-time threats, we're looking at the evolution and the development of storms. And Bret, coming up in a moment, is going to talk about what radar is and the differences between some of the products. I'm going to spend a little bit more time focused on what radar is, how it works, what the shortcomings are, and how you can use it as a tool to make decisions. Radar, simply put, sends out a pulse of energy and then waits for that pulse of energy to return back to the radar. The majority of the time that a radar is operating, it is listening. It's over 90% of the time. Radar knows a lot of things. The processors know when the piece of energy was transmitted, how long it took to get back to the radar, what the speed of light is, and it takes all of this information and it gives us a display that we know and love, radar echoes, or as a meteorologist would call it, reflectivity. You can see a picture of what a radar looks like if you haven't been up close and personal with one, and you can see a radar image there in the lower part of the screen. This is a basic idea of how radar works. Pulse of energy goes out, the pulse of energy comes back most of the time, at least in part, and radar processors create the image that you see there in the upper right part of the screen. So we're simply dealing with pulses of energy and what happens to that energy by the time it returns to the radar. But it's important, especially with products showing up more and more on more and more devices, that you know what base and composite reflectivity is. Again, reflectivity, another way for saying radar echoes, but we'll use the term reflectivity here to describe the difference between base and composite. Base reflectivity is defined as the lowest elevation scan radar imagery from a single radar site. So the visualization in your mind, you picture a radar beam going out, sweeping the sky, tilts up a little higher, scans the sky again. Technically, all of those different scans are base reflectivity. But going forward as a pilot, and when meteorologists are talking to each other about base reflectivity, they're referring to the lowest elevation scan from a single radar. That is different than composite reflectivity. That's the display of the maximum reflectivity from all of the different elevation scans over every single point a single radar samples. For example, let's say we have a radar and we have a nearby town, and there's a storm on top of that city. Radar will scan at the lowest elevation angle. It will tilt up a little bit more, scan it again, and it will do this for several different scans, especially in convective modes. Now, as the radar beam is slicing through that storm, it's looking for how much energy is returned. Now, for some of those scans, more energy will be returned to the radar. And that's ideally what we're looking for when we're looking at a composite reflectivity image. For every point over a given radar sampling area, what is the maximum reflectivity value? Important word there, maximum. So for a given radar, storms will almost always appear stronger in composite reflectivity compared to base reflectivity. That's again tying back to the word maximum reflectivity when we're referring to composite reflectivity. Here's an example. On the right side of the screen, we have a base and a composite image. Got a guess for which one is which? If you think the image on the right is a composite reflectivity image, you are correct. The image on the left is a base reflectivity image. The giveaway there, this cluster of storms appears stronger on the right, and that's a pretty good sign that that is going to be our composite reflectivity image. So which one should you use? Well, if you're a pilot flying to altitudes above 10,000 feet, you should pay closer attention to composite reflectivity, because composite reflectivity is a better representation of a storm's strength vertically. That's not the case if you're a lower altitude pilot. If you're a lower altitude pilot, base reflectivity is more important during takeoff and landing, and for lower altitude pilots, because base reflectivity provides a better indication of precipitation intensity closer to the ground. As an added bonus, base reflectivity is helpful for detecting boundaries, including outflow boundaries, which can create wind shifts and can be hazardous to your aircraft. So the screaming message here is that you should know how radar works at a basic level. You should know the difference between base and composite reflectivity. Simply put, base reflectivity sampling the sky closer to the ground, composite reflectivity, taking all of the radar scans and finding the maximum reflectivity value over all the points the radar samples. Now, we don't cover it here, but we do cover it in some of our additional content on the Takeoff app. We talk about mosaics. We go into detail about differences between base and composite reflectivity, so I encourage you to look there. But if we take all the composite reflectivity images and we stitch them together, we get what is called a mosaic. Now, worth noting, if you have ForeFlight or you have a device in the cockpit and you're looking at base and composite reflectivity, radar vendors often do some additional processing of that radar information. They may be clearing up false echoes, or anomalous propagation is the more scientific term. Just know that there's some quality controlling going on in the background, but the general rule of thumb is the same. You're looking at red, you're more than likely looking at very heavy rain. You're looking at a vertically developed storm, and you're probably looking at hail. Weaker reflectivity values, usually an indication of light to moderate precipitation, including rain, but possibly snow, and radar can also sample plumes of smoke and the like. We've covered a lot of ground here, so it's important to focus in on these important takeaways. As I alluded to earlier in the presentation, just because there's bad weather in front of you doesn't mean it needs to be around you. In fact, I highly discourage it. Talk to ATC, adjust your flight plan, do whatever you need to do to avoid hazards. And just because it wasn't showing up in numerical guidance, just because it's not showing up on radar, make a decision as you look out the window and trust your instincts. Trust your experience as well. The technology is there to help you, but it's not there to act as your brain and make decisions for you. Something else worth noting, and you see a good example of it here. Check your timestamps. In this image, the actual clock time is 1:55. The radar image is at 1:50. So we know that this is a fairly recent image, but we should never assume that weather data is live. There's always going to be a delay to collect the weather information via radar, a ground station by a satellite, to package that information up, send it up to a satellite, and then send it back down to your device and airplane. So check your timestamps. That can give you an indication of how current your data is, whether storms are strengthening and weakening, what has changed since your last update, and if you can, loop the radar. That can give you an indication for whether storms are intensifying, weakening, what hazards may be developing. Trust your instincts. Technology is great, but nothing beats a pair of eyes and a whole bunch of experience behind the yoke. Weather data is guidance. It is up to you every single time to make the right decisions for your safety and for your passengers' safety. Weather is a hazard. Whether it's clear air turbulence or it's a line of nasty thunderstorms, make sure you're up to speed on what the forecast is, how the TAFs, how the longer term guidance is evolving. When we get into the cockpit, or we are getting ready to get into the cockpit and take off, look at the radar imagery, look at the satellite imagery. Is what we thought a few days ago matching up? Is what we thought a day ago matching up with what we were thinking right now? And once we get into the airplane, be alert for changes. You may have to adjust your plan because that line of thunderstorms is intensifying and it just refuses to give up. This data is great. We live in a great time. We have great tools in our hand and at our fingertips, but it does not replace your own decision making. Now it's time to go back into the cockpit. I will hand back over to Brent, and he will give us some great examples of how we can use data link weather once we're in the plane.
Thanks, Scott. And so we're going to take the information we learned up to this point in the presentation. Again, two scenarios up to this point. We have a go, no go decision. We're going to assume there is some convective weather out there for a flight through a couple scenarios here, and we made the decision to go. With these in-flight weather tools, in my experience flying with data link weather, really since even before ADS-B became mainstream with the XM weather product, I found that having these tools in the cockpit allows me to make flights that I normally would have stayed on the ground because I'm able to keep up with the weather, the motion. My flights might get a little bit longer. I might be deviating around weather more, might be taking a longer flight path. Again, using the tools we looked at earlier, might be shifting my departure time a little bit, but it makes it manageable. It's not just a no-go decision, wait till the next day. Having this information in flight really augments that and makes you feel a lot more comfortable with your decision once you do get up in the air, and keeps your visuals of what you're seeing around you up to date. So as Scott mentioned, the two main weather products for getting in-flight weather are ADS-B, and I'll point out one product here, product called Stratus. Again, for those of you flying with FliGht, this will deliver that subscription-free weather radar imagery, METARs, TAFs, etc. into the cockpit. It does have a built-in GPS, so it'll satisfy the needs of your moving map navigation in FliGht. Also delivers traffic, a backup attitude display, built-in 8-hour battery, so it's completely wireless, and uses Wi-Fi to connect to your iPad. All that for it's $8.99. And best part there, once you buy the product, you are getting a subscription-free weather feed from the U.S. government in the United States, so no monthly subscriptions for that product. On the other end, SiriusXM is really starting to take over again as far as a viable weather product, and seeing a lot of pilots add this to their iPad. It's been around really since I think the early to mid 2000s, starting with the Garmin 396 handheld GPS. That was really a lot of our, as pilots, our first introduction to data link weather, and it was really an eye-opener at that point. Now we can take the SiriusXM, the combined product of those two companies, their satellite weather product, and also deliver that to the iPad. Similar features as far as GPS that the ADS-B products deliver. But what you're going to find with the SiriusXM is some additional weather products. It's got a higher resolution radar imagery. Has the option to display your choice of either composite or base radar reflectivity, as Scott just outlined earlier, the differences there. So it gives you a little more information based on the altitude you're flying at and which product you might want to look at. Includes lightning data and echo tops. Some more analytical tools related to convective weather in the cockpit. Also has some icing and turbulence products as well that you can keep an eye on in flight. Now, for these premium features, it's a commercial provider. There is a monthly service fee. $39.99 is the starting price for that product. But on the non-weather side of things, you have the option to add satellite radio entertainment. So for those longer flights, you can listen to XM music, talk radio, etc., if that's an interest to you. As far as the products go right now, the SiriusXM SXAR1 product matches up with FliGht. And then Garmin just released two new products, the Garmin GDL51, which is a SiriusXM receiver, and the GDL52, which is a combination of SiriusXM and ADS-B weather, kind of the all-in-one ultimate weather box for Garmin Pilot. So those are your mainstream options at this point for in-flight weather. So Scott showed some pictures earlier of base versus composite reflectivity, and I want to give you a feel for what it actually looks like in the cockpit. So again, those lower altitudes coming in for landing with flying in weather systems, the base reflectivity is going to give you a better feel for what precipitation is actually hitting the ground. What is the intensity of the precipitation you're going to be flying through at those lower levels? Or the composite reflectivity on the right side is going to give you a better feel for the intensity of the storm system as a whole. The darker colors there obviously stemming from more precip and returns at the higher altitudes in this example. And even if you don't have SiriusXM in this product, FliGht does offer base and composite reflectivity as an internet weather source. So even if you're not using it in flight, you can start to experiment as weather moves through this summer and take a look at the base versus the composite and start to see the differences there with different weather systems, as you can toggle that on and off on the FliGht weather layers on the moving map screen. So why might somebody want to choose SiriusXM over ADS-B? Common question. And on most flights, I fly with both of these products, and they're both great. But SiriusXM does have some advantages, again, that you're paying a premium for. Being that it is satellite-based, you get coverage all across the U.S. On the ground, in the air. Altitude does not matter because it's a sky-based signal. It also has coverage further into southern Canada, sometimes up to 50 to 100 miles. So pilots flying in the southern parts of Canada are likely to get a much better signal and better coverage compared to ADS-B, which will just provide coverage really along the border of the US and Canada. Mentioned earlier, the storm tracks, tops, and lightning overlays, so it's going to give you more analytics on the actual thunderstorm activity. And this can be useful for the high altitude flyers if you're trying to top a weather system. Maybe not a severe line of storms, but some thunderstorms that you can get up in the high 30,000 foot or low 40,000 foot level to try to top that weather. that Sirius XM can give you some altitude information about that weather in flight. On the southern end, as far as the coverage goes, it does extend further down into the Bahamas as compared to ADS-B. So getting down towards Nassau and those areas, you can get coverage, radar imagery. And of course, I mentioned the XM radio for the entertainment value there. Okay, so I want to share with you as we conclude here at the end a couple scenarios of some flights we've taken over about the last 3 or 4 years, and some mindsets, some thought processes you might want to think about as you're flying with this data link weather during convective weather and the radar imagery as we see here displayed on the images. So number one, a very important point is that this product is not used for, or to be used for, close navigation around thunderstorm cells. So we're not going to take this product and treat it like it's onboard radar. Scott mentioned this typically is 5, 10, even sometimes 15-minute old data. So it's moving. It's not going to be exactly where it says it is on the chart. But if we give ourselves 40, 50-mile wide berths around the weather, especially if we can't see it, we're going to be playing it very safe. Now, the best thing is to keep an eye on it. Again, as Scott mentioned, you want to keep a visual on the weather. Don't just depend on the cockpit tools. But what these tools are good for is planning a route around the weather before you can even see it. So if you can get a good feel for 50, 100, even 200 miles out and start to plan a deviation way around the weather, as in this flight example here, it's going to make your life a whole lot easier. So don't get right up to the weather, request a 30-degree deviation around it, and then have to cut back on course around it. That's not very efficient. Talk to air traffic control way out in advance. Use the touch planning tools in ForeFlight. Pick a VOR, pick an intersection, tell air traffic control where you want to head, and plan a route around that weather. And again, these are the tools that you can use that you may have canceled a flight previously because you couldn't have kept an eye up on how the weather evolved. Well, now you can see it an hour or 2 hours into a flight, how the weather is evolving, and change your route accordingly. And you're going to find air traffic controls pretty flexible with you, as long as you give them plenty of time to work out a route. And so this is the view here of that weather system going way out around it. Off to the right there looks pretty ominous, but we were probably a good 100 miles away from any of the bad stuff in this case, so worked out really well. Okay, next scenario. We typically assume weather patterns, and typically they do move from west to east as the following along the jet stream, the wind flows across the United States. So here's a scenario. We're coming back into Cincinnati. We see a line there. Looks like a cold front, right? Maybe just move through the Cincinnati and Ohio River Valley area there, back towards Claremont County, home of Sporties. But what we're going to find out here is that weather pattern was actually shifting pretty far south in the movement there. And so what we'd want to do in this case is use the play button there in the bottom left-hand corner to animate the weather. And it's going to play the saved frames stored on your iPad that was sent from the weather product, so you can get to see a trend of the motion of the weather. Because what you're going to find out here in this case, as we got closer, that weather shifted pretty much due south and made Cincinnati, or Claremont County in this case, India 69, not an option for landing. So we actually ended up deviating to Greater Cincinnati International Airport in this case. So here's a scenario where there's a pretty identifiable line. We're, of course, not going to fly through it. We had plenty of alternate options. So we flew up to the weather, realized we couldn't make it, and made a diversion. But got a lot closer to home along the way. But during that process, we were continuing to watch the trend of the weather through that animation process, watching where it was heading. And we started to plan ahead as we got closer that we probably weren't going to make it back into our planned destination airport. So this example here was a flight from Cincinnati to Frederick, Maryland. And this does a couple things. First off, it shows how you can use this weather data in context with approach charts, sectionals, your runway layout, especially when you have a lot of weather nearby your destination airport. Now, on a flight like this, we would typically, due to Potomac approach requirements, we would overfly the airport just to the south up to the Westminster VOR, which is at the top of the screen there, or the top right of the screen, right over here. And what would happen if we did that? We would have been right through the reds and the oranges of the weather system. I'm not comfortable. And what they typically have you do is intercept the ILS from the east side of the localizer there and come on in. So we told Potomac Approach, having a good view of this, probably about 50 miles out, and said, hey, the typical routing's not going to work. Can we get a vector to the ILS from the west side? And they said, hey, yeah, sure, no problem. And easy as that, kept the flight smooth. Didn't hit any really strong weather, any kind of convective weather, and made a nice, easy landing into Frederick. So you're the pilot in command. Take this information, make a decision, talk to air traffic control. They're there to work with you. Don't always just take their guidance or their instructions, especially if it puts you into some weather you don't want to fly into. But again, having these tools makes your decision making much easier, and having much more education about what's going on around you to give you and your passengers a smoother flight. Okay, last thing I want to end on, we talked a lot about weather radar imagery. Keep in mind the ADS-B weather products, SiriusXM, also delivers updated METARs and updated AWOS information in ForeFlight. And beyond just looking at a METAR, consider turning on the ceiling, the visibility, or the winds layers. And what we're looking at here in this example is a flight back to Cincinnati, again, where we're based. And I've got the ceiling label on. And so you can see up further north, there's a lot of IFR weather. Into Indiana, pretty well VFR. Not really a big issue today for landing, but I've been on a couple of flights when it comes down to 400 or 500 foot ceilings. And that's the difference between making an instrument approach and landing at the destination airport versus having to divert. So over the course of that last hour, I was keeping an eye on the trend of the ceilings. Were they going up? Were they going down? Just by keeping this view on here with the ceiling data. Same thing with visibility, same thing with wind. So make it a habit to use more than just that radar imagery. As we get a closer look here, see like Lunkin here at Cincinnati is showing 1600, meaning that the ceiling is broken at 1600. So what other weather limitation there might be for your destination airport, check that out and display it on the moving map along the way to give you more information about the flight. Okay, with that, we're going to conclude. As Scott mentioned and I've mentioned, we have a called the Takeoff app from Sporties. Just like this presentation here is continuing education for pilots, consider the Takeoff app a continuing education on your iPad or iPhone. We publish several pieces of content daily, weather-related, flight maneuvers, real-world advice on using ADS-B weather, etc. Free app. There's also premium content available in there. Scott is one of our featured presenters and contributors to the Takeoff apps. So you'll find a lot of content from Scott in here, available on the App Store for your iPhone and iPad. Okay, with that, we're going to wrap up. Again, this presentation will be available in its entirety at sporties.com/webinars. We'll also have it available on the Sporties YouTube channel, probably tomorrow afternoon. Coming up in May, we'll have our next webinar called Surviving the Check Ride, Thursday, May 30th at 8 p.m. And then on to June, we have a ForeFlight presentation on how to get the most out of ForeFlight with one of their senior engineers and designer. And that ForeFlight webinar will be on Thursday, June 28th. With that, I want to thank Scott Dimmich again for joining us and presenting lots of great information. From all of us here at Sporties, have a good evening. Thank you.